Hello and welcome to this video about percent problems. So in this video, we're going to talk about how to solve problems that involve using percentages. And what we're going to see is that there are two types of problems that we're going to run into. All right, one type is where we just either do some multiplication or division. All right, and so our hint here is we're going to be looking for the word of. All right. Now, it may be a hidden of, and we want to kind of like keep that in mind because that's going to help us realize if we need to multiply by our percent or to divide by our percent. All right. Now, the other one is where we have to multiply and then add or subtract. Now, this is the more complicated and perhaps the more fun problem to work with. In this one, we kind of have a bit of a formula here. What we're going to do is we're going to take the original plus or minus the original times the percentage, and that's going to equal our new. Okay? So again, this stands for original, and then this is our new, and then finally we have our percent. All right, and when we do this, make sure that you're using this as a decimal, all right? And then the plus or minus part, this comes from context, all right? So if we're building something up, it's gonna be plus. If we're taking something down, it's gonna be minus. So let's look through some examples, and I think that will help us with all of this. So I've got a couple of examples. In example number one, let's say in a class of 30 students, 60% have a dog. How many students have a dog? Well, I'm seeing my little indicator word of, all right? And of itself means multiply. So essentially I have 60% of 30 students is going to equal how many of them actually have a dog. So in this case, I can go with 0.6 times 30, and that will tell me how many students have a dog. So 0.6 times 30, that is equal to 18. So 18 students have a dog. So that's number one. Now, let's compare and contrast that to number two. What I did is I wrote these problems to be very, very similar here. So that way we can kind of hopefully pick apart the differences and how to approach them differently. So in number two, if there are 30 students with a dog, there should be an and, that is 60% of the class. How many students are in the class? Oh, all right, very interesting. So we have 60% of the class, which we don't know, all right, so the class equals 30 students. So now, the reason why, again, it's important to have that of is we can see how we're going to be multiplying things together. Now, the thing is, the class, that's an unknown. That's x. So I have 0.6 times x is equal to 30, and now it's more obvious to me that what I should do is divide both sides by 0.6. Divide by 0.6. So 30 divided by 0.6, that ends up giving me 50. So there are 50 students in the class. And then again, 30% of them, 60% of them have a dog, and that would boil down to 30 of them have a dog. All right, now let me clean that up a little bit. So those are the ones where we just multiply or divide, all right? Here, we're gonna have to use the formula. And so what I wanna do is I wanna write it out. Again, the original plus or minus the original times the percent is equal to the new. All right, a class of 32 students lost 12.5 of its students over the summer. How many students are in the class in the fall? All right, well, what I'm doing is I'm looking for the new amount. All right, so I have a class of 32, and then over the summer, 12.5% of them are moving out. So I'm taking that original, I'm losing, so I'm going to be using subtraction, 32% or 32 students, but I'm now going to times that by my percentage. So that's 0.125. And then I crunch those numbers, and that's going to tell me how many students there are in the fall. So 32 minus, and then let's go 32 times 0.125. That gives me 4. And so I have 28 students in that class in the fall. Next, let's look at number 4. An item is listed at $110 and it's 35% off. How much cheaper is the item? Okay, so now this one, I wanted to bring this up because I want to show you that sometimes what we might do is see a problem that looks like this, but we only want this part, all right? We're looking for just how much money is off. So this actually kind of boils down to a multiplication. So all I'm going to do is take 110 and I'm going to times that by 0.35, my 35%. So 110 times 0.35, it is $38.5 cheaper because it's 35% off. All right, now, these are the basic examples, okay? Again, it boils down to, are we multiplying or dividing, or do we have to use this formula? Where it gets a little bit harder is where we need to use the formula and we have to put some more unknowns in there. All right, so again, I'll write the formula. We have the original plus or minus the original times the percent is equal to the new. All right, number 1, Taylor spent $56.10 on an item that was on sale for 15% off. What was the original price? Well, what I got to keep in mind here is that this is not the original price. That was my quote-unquote new price. So I'm going to put 56.10 over here on this side of the equal sign where the new is. I don't know what the original price is. So what I'm going to do is I'm just going to put X. That's what I'm trying to find. And then it's on sale, so 15% off, that means it's going to be minus, or taking off 15%. And I'm going to kind of jump the gun here. 15% is 0.15 times my original, which is just X. Now this is where it gets tricky. What I need to do now is figure out, or I want to combine my like terms. So I want to think of this as 1x minus 0.15x. That's 0.85x is equal to $56.10. Now I'm just using my solving skills and I'm going to divide by what's being multiplied to x, 0.85, 0.85. So 56.10 divided by 0.85, x equals 66. So the price for the original price was $66. All right, finally, let's look at number 2. When a large family went out for dinner, the restaurant automatically added an 18% tip to their bill. Find the cost of just the meal if they paid $193.52. Now again, what makes these quote-unquote harder examples is that we're given the new and we have to find the original. So again, this is after that tip was applied. So I'm going to put this on the right-hand side, 193.52, and that's equal to my original cost, which I don't know. It said that this was added to their bill, so context clues, I need to add instead of subtract, and then it's going to be 0.18x. So this represents my 18% of the bill that was added. So again, keep in mind, this is just 1x. I can combine my two like terms here to get 1.18x is equal to 193.52. Now, again, this is no different than saying 2x is equal to 4, divide both sides by 2. Here, divide both sides by 1.18, divide by 1.18, and this is why we allow calculators on this section, because that would be rather nasty to have to do by hand. And when we do that, we get x is equal to 164. So that means that the original cost of the meal, the raw meal itself, well, not raw, but without the tip, was $164. So again, this is how we do percent problems. Main thing we want to keep in mind here, we have what kind of problem are we dealing with here? Are we dealing with just a multiply or a division? Or do we have to use this formula right here? Original plus or minus the original times the percent is equal to new. Good luck with your homework or practice, and let me know if you have any questions.